We present GONet, a semi-supervised deep learning approach for traversability estimation. GONet takes as input an image of the environment captured from a fisheye camera on a robot, and outputs the probability that the input image depicts an area that is safe for the robot to traverse. GONet can deal with challenging scenarios. It can detect blocked paths and unsafe areas such as stairs, fences, and windows. At a high level, we formulate the problem of estimating traversability as an anomaly detection problem. Positive images, which GONet expects to get as input, depict traversable areas, whereas negative images that show obstacles and dangerous elements in front of the robot are considered outliers. GONet's goal is to distinguish between these two types of inputs. The proposed approach works as follows. At its core, GONet checks if the input image looks like a traversable area using a generative adversarial network. This network is trained with vast amounts of positive examples, such that it generates an image that looks like a traversable area. We constrain the generated image to also resemble the input. For instance, when the input is indeed traversable, as shown here, the generated image will look very similar to it. But when the input is non-traversable, the generated image will look different. Based on this difference, GONet finally predicts traversability. This final classification step is trained with a small set of positive and negative examples, making GONet more accurate than fully unsupervised baselines. Here we show example images that were generated internally by GONet. At the bottom, we also show the output probability of the model. Note that when the robot approaches the shiny elevator on the left, the predicted image differs significantly from the input, and GONet outputs a low probability. But when the robot moves away from the elevator, the predicted image is more similar to the input, and GONet correctly outputs a high probability. As part of our contributions, we also present two extensions of GONet. The original GONet model assumed that every input image is independent and identically distributed. But this is not true for images from a video stream, as captured from a robot. Any observation is dependent on the past, and this past can often help understand whether the current view of the environment shows the traversable area or not. The first extension that we propose in this work uses a recurrent neural network to account for dependencies on past observations and enforce temporal consistency on traversability predictions. Our second extension also enforces temporal consistency, but instead of taking a single color image as input, it predicts traversability from stereo pairs. This approach increases accuracy by 4% in comparison to our vanilla method. We now present some example results where we use the proposed approaches as a visual emergency stop switch. In this video, a person teleoperates a TotalBot towards a glass wall. GONet sees the environment through a fisheye camera on the robot and overrides the operator commands to prevent the TotalBot from colliding. Because GONet operates in real time, it can also prevent collisions with objects that suddenly appear in the robot's way. From our experiments, we noticed that the most challenging scenarios for GONet included situations where the robot encountered very small objects, like a mouse. In general, GONet was able to deal with challenging deformable objects, like these wires. But sometimes, it detected these obstacles too late, after part of the wire was underneath the mobile platform. We're now conducting more experiments with GONet to understand how robust it can be in completely different scenarios than what it was trained on. For instance, We began tests of GONet outdoors. We gave a fisheye camera to a blindfolded person and explored using GONet as an assistive device. Traversability was computed in real time on a laptop in the user's backpack. When a non-traversable area was detected, an audible message was automatically generated.
Warning, danger. Warning, danger.
Note that GONet was never trained outdoors before. For more details and results, please see our paper.